All right, so we'll continue on in our lessons on Introduction to Statistics, Part 2. So what we're going to talk about in this lesson is understanding and being able to calculate the 5-number summary of a data set, and then we'll also talk about calculating weighted averages. So the 5-number summary of a data set includes these 5 values: the minimum value, the lower quartile, which we'll talk about in a minute, the median, the upper quartile, and the maximum. Okay, so the minimum is the smallest value in the data set. So again, write your numbers smallest to biggest to get these. The lower quartile is the median or the middle of the lower half of the data. The median is the middle number, same as what we did before, so that definition stays the same. The upper quartile is the median of the upper half of the data set, and then the maximum is the biggest value. Okay, so we'll learn to calculate these, and I've got a few different examples for you just because depending on the number of items in the data set, these definitions stay the same. There's just different ways they could come. Like for instance, when we calculate the median, sometimes we're taking the average of the two middles and things like that. So make sure that you get through all 3 examples so you could see how these are working. Okay, example 1, find the 5-number summary of the data set. So we have the data set there, and the first thing that we do is we put the numbers in order from smallest to biggest. So we have 15. I'm looking on my paper so I make sure I get these right. But when I do this, as I mentioned, I find the smallest, cross it off, and then keep going. Okay, so I have my data set written in order of smallest to biggest. I typically find the minimum, then the maximum, median, and then I go for lower quartile or LQ, and upper quartile, UQ. So the minimum is the smallest, the maximum is the biggest, and the median is the number that's in the middle. Okay, so I'm not going to cross them out here. Just because we're going to need them in order to, it would just be too messy when going to find the lower quartile and upper quartile. Okay, so use your fingers or your pencil and cover up numbers until you get to the median. So in this case, the median is 25, which means that half the numbers in the data set are above 25 and the other half of the numbers are below 25. So what this median does is it splits our data set in half. So now what we can do, and let me get a couple of different colors going here. Okay, so this is our lower half, not including that median value. Remember, everything is above and everything that's below that median. So we have our lower half and we have our upper half. Okay, so once we've identified the lower half of the data set and the upper half of the data set, we can find our lower quartile and our upper quartile. So lower quartile is the median of the lower half. Maybe I'll cross these out in yellow. So 21 is our lower quartile number. And then we would do the same for the upper quartile, which would be 27. Okay, so the minimum is 15, the maximum is 32. Right in the middle is 25. Then we have the upper half of the data set, which has a median of 27. So that's our upper quartile. And then our lower half of the data set has a median of 21, so that is our lower quartile. Let's look at another example. So we have another data set here. I'm going to write them in order, and then we'll get started. Okay, so in this example, again, I usually go for the minimum, the median, and the maximums first, just because they're the easiest to identify. So the minimum is 5, The maximum here would be 54. And then the median. So again, use your fingers or your pencil. Here in this case, the median is in between 27 and 28. So what number is in between 27 and 29? The median here is 28. So this is the middle. Okay. So 28 is our median in this case, and you can also get that by taking 27 plus 29 and dividing it by 2. You get some other colors. So now the lower quartile actually includes the 27 because it is not the median. So the median is 28. That's the number that cuts our data set in half. So everything above 28 is the upper half, and anything below 28 is the lower half. This is different from the previous example in that when we had 25 as our median, it didn't count as part of the lower quartile or the upper quartile because it was the exact middle. But in this case, when our median is between those two values, the two values used to calculate the median are part of the lower or the upper half of the data set. Okay, and so here's our upper half. And so now we calculate the median of the lower quartile. So I'm going to cross off values. And so we've got two numbers in the middle. So in order to calculate the median, or the lower quartile, which is the median of the lower half, we take 14 plus 21 and divide by 2. So it would give us an LQ of 17.5. Okay, and then over here, for the upper quartile, we cross off our numbers. And then again, we have 2. So what's in between 36 and 37? Which would be 36.5. Okay, another way to check that you're splitting your data correctly is you should have the same amount of data points or data points in the lower half and in the upper half. So for instance, we have 1, 2, 3, 4, 5, 6 numbers. We should have 1, 2, 3, 4, 5, 6 here. Okay, same with the previous example. We should have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so you should have the same number of data points in the lower and in the upper. And let's go to example 3. So again, finding the 5-number summary. So I'll write these values in order. So we have 955, 955, 956, 957, 960, and 971. Okay, so again, we'll start with our minimum, 955. Our maximum is 971. And then let's look for the middle value. Okay, so in this case, if we're going along, our middle value is going to fall right here in between 956 and 957, which would be 956.5. Okay, and so now we have our lower half and our upper half, and you can make sure you did it right. There's 3 values in the lower half, 3 values in the upper half, which means that you found the middle of the data set. And so in order to find the LQ, in this case, it would just be 955, and the UQ, which would be 960. So those are a few different examples of how your median could fall when you're talking about the median of the data set, or the lower quartile and the upper quartile. Okay, next what we're going to talk about is weighted averages. So an example of a weighted average is the course grade. And what happens with this is that some categories have more pull or sway over your grade. So for instance, I've listed the categories of how your grade works in this class for Math 120 CX. So 10% is mini projects, 10% is MyLab, 30% is tests, 30% is projects, and 20% is the final exam. So the categories that have more pull over your grade are the tests and the projects, because those are 30% each. So 60% of your entire grade is going to come from those 2 items. The categories that have the lowest pull over your grade are mini projects and homework. Okay. Another example of weighted averages is GPA, and the way that that's weighted is by credit hours. An A in a 5-credit class is different or has more pull than an A in a 1-credit class, so it's based on those credits there. So we're going to do an example with calculating GPA. So the way or the reason that the GPA is a weighted average is because we're still going to use the principle of averages where we add up the number and then divide by the total number of items. But here, when we're adding this up, it's our sum of points, or another way to say that is the sum of each grade times credits. divided by total number of credits. Okay, so in this case, we have the courses listed and the weight that each grade carries. So for instance, an A carries a weight of 4, a B carries a weight of 3, a C carries a weight of 2, and a B carries a weight of 3. So what we do in order to calculate this weighted average is in the numerator, we take each credit times the grade, so 3 times 4, and this is for math. We add that to 3 times 3, which is for English. We add that to 4 times 2, which is for history. And then we add that to 1 times 3, which is for lab, divided by the total number of credits. So for the total number of credits, we're adding up the total. It's almost like if you take 12 credits a semester or 15, that would be your total number of credits. So this is 11. Okay, so you do the calculation in the numerator. So this would give us 12 plus 9 plus 8 plus 3 divided by 11, which gives us, if you add those all up, 32 divided by 11, and we'll go to the nearest hundredths place, which would be a GPA of 2.91. So the reason it's a weighted average, again, is because some of these classes, for instance, history has more pull over the grade than the lab does, because there's more credit hours for the history class. Okay? And just kind of an interesting thing to look at, 2.9 is really close to 3, so this person's looking at probably close to a B average for their grades. Thank you for watching. If you have any questions, please feel free to reach out to me.